SpaceX just revealed their version 3 booster, and everyone wants to know what's so special. Rocket Lab's US military cargo test. Hey, I'm Lucas. Welcome to the SpaceX community. Let's get started. Finally, we get to see SpaceX's new version 3 Super Heavy booster, a critical component of the Starship system designed for future Starship flights. This detailed video by Starship Gazer of the booster, captured in a pre-launch or assembly phase, offers a glimpse into the engineering marvel that powers SpaceX's ambitious missions. The V3 iteration represents an evolution in design, incorporating lessons learned from previous tests and aiming for enhanced performance, reusability, and reliability. The V3 Super Heavy booster is a towering cylindrical structure made of stainless steel, a material choice that has become synonymous with SpaceX's Starship design philosophy. The stainless steel construction, visible in the reflective surface of the booster, provides durability and heat resistance, crucial for withstanding the extreme conditions of launch and re-entry. The image highlights the booster's robust build, with multiple circular ports and attachment points along its midsection, suggesting the integration of advanced propulsion systems and structural reinforcements. The presence of numerous cables and mechanical arms indicates ongoing assembly, a testament to the hands-on approach SpaceX employs in its iterative development process. One of the most striking elements in the image is the array of Raptor engines mounts at the base of the booster. The V3 Super Heavy is designed to house up to 33 Raptor engines, a significant increase from earlier versions, providing a combined thrust that exceeds 17 million pounds. The engine mounts, partially visible in the lower part of the image, are arranged in a circular pattern, with some covered by protective caps or connected to testing equipment. This configuration allows for redundancy and efficiency, ensuring the booster can operate even if one or more engines encounter issues during flight. The Raptor engines utilize a full-flow staged combustion cycle and burn methane and liquid oxygen, methalox, a fuel combination that supports SpaceX's goal of in-situ resource utilization on Mars. The upper section of the booster features a complex network of wiring and structural supports, hinting at the integration of avionics and control systems. This section is critical for the stacked configuration of the Starship system, where the Super Heavy booster provides the initial thrust to escape Earth's gravity, followed by the Starship upper stage taking over for orbital insertion and beyond. The presence of a small triangular framework near the top suggests ongoing modifications or the attachment of additional hardware, possibly related to the booster's grid fins, which are essential for controlled descent and reuse. Also, the weight of 27,000 pounds indicates the substantial mass of the support structure, separate from the booster itself, underscoring the scale of infrastructure required to handle such a massive rocket. This detail highlights SpaceX's investment in ground support equipment, which is as crucial as the rocket itself for achieving rapid turnaround times between launches. The V3 Super Heavy booster's design evolution is a response to the challenges faced during previous test flights. Earlier iterations experienced issues such as engine failures, structural stresses, and landing mishaps, which SpaceX has addressed through iterative improvements. The V3 version likely incorporates enhanced thermal protection, improved engine reliability, and refined control algorithms. The visible patchwork on the booster's surface, with some areas showing weld marks or repairs, suggests ongoing refinement, a hallmark of SpaceX's rapid prototyping approach. This hands-on development process allows the company to test, fail, and improve in real time, accelerating the path to operational status. From a technical standpoint, the Super Heavy booster's design reflects a balance between power and efficiency. The 33 Raptor engines are divided into sea-level and vacuum-optimized variants, optimizing performance during different phases of flight. The sea-level engines, with their gimbaled nozzles, provide thrust vector control for steering, while the vacuum engines enhance efficiency in the upper atmosphere. This dual-engine approach, visible in the varied configurations at the base, showcases SpaceX's innovative engineering to maximize thrust while minimizing fuel consumption. I'd like to quickly remind you to subscribe to our channel if you haven't already. We regularly upload informative SpaceX and space news videos that you won't want to miss. Be sure to turn on the notification bell so you're notified whenever we release new content. Rocket Lab, a trailblazer in the commercial space industry, has achieved a significant milestone with its next-generation Neutron rocket being selected for an experimental mission under the U.S. Air Force's ambitious Rocket Cargo program. This initiative, led by the Air Force Research Laboratory, AFRL, aims to revolutionize global logistics by leveraging commercial launch vehicles to deliver critical materiel to any location on Earth within hours. The mission, scheduled for no earlier than 2026, marks a pivotal step for Rocket Lab, as it expands its footprint in the national security launch market, a sector traditionally dominated by larger aerospace giants. The AFRL's Rocket Cargo program envisions a future where spaceflight serves as a high-speed logistics solution, akin to traditional airlift capabilities, but with the added advantage of global reach and unprecedented speed. The concept is to use reusable or expendable launch vehicles to transport cargo into low Earth orbit, LEO, followed by a controlled re-entry to deliver payloads to precise locations worldwide. This approach could transform military logistics, enabling rapid response to crises, disaster relief, or troop support in remote regions. The program is still in its early stages, described by Rocket Lab's founder and CEO, Peter Beck, as being in an experimental phase. Speaking during first quarter earnings call on May 8, 2025, Beck emphasized the nascent nature of the initiative within the U.S. government. "The Rocket Cargo program is really at the very beginning of its development," he said. "We're very much in the exploratory stages, and it will be fascinating to see if this evolves into a fully operational requirement." The experimental mission awarded to Rocket Lab will serve as a survivability experiment, testing the Neutron rocket's ability to carry a payload into orbit and safely return it through Earth's atmosphere. This test is critical to validating the rocket's capability to withstand the harsh conditions of launch, space travel, and re-entry while ensuring the payload remains intact and functional. The mission will also be a multi-manifest launch, meaning the Neutron rocket will carry multiple payloads, showcasing its versatility and capacity to handle complex mission profiles. The Neutron rocket, Rocket Lab's answer to the growing demand for medium-lift launch vehicles, is designed to deliver up to 13,000 kilograms to low Earth orbit. This capability positions it as a competitive option for both commercial and government missions, bridging the gap between smaller launch vehicles like Rocket Lab's Electron and heavy-lift rockets like SpaceX's Falcon 9 or United Launch Alliance's Vulcan Centaur. Neutron's development is progressing on schedule, with its inaugural launch targeted for 2025. The rocket is being developed at Rocket Lab's facilities, and a dedicated launch pad is under construction at Wallops Island, Virginia, a strategic location for accessing a variety of orbital inclinations. Beck reported that both the rocket's development and the construction of the launch infrastructure are on track, reflecting the company's disciplined approach to meeting ambitious timelines. Unlike Rocket Lab's Electron, which is tailored for small satellite launches, Neutron is designed with scalability and versatility in mind. Its payload capacity and ability to support multi-manifest missions make it an ideal candidate for the AFRL's Rocket Cargo program, as well as other national security missions. The rocket's design incorporates advanced technologies to ensure reliability, cost-effectiveness, and rapid turnaround times, aligning with the US government's push for responsive and agile space capabilities. Thanks for watching today's episode. Don't forget to subscribe and give us a thumbs up if you enjoyed it. Stay tuned for another great video tomorrow.